All right, biotech, this is our first lecture. So today we are going to talk about laboratory safety. So this is part of our laboratory skills unit, and we will be working on skills for the next bit. So this first bit is safety. So the very first thing, when people are onboarded onto a new lab job, their first week or so is just lab safety. So part of onboarding, or when you start a new job, you are going to be starting that job just learning how to do lab safety. So for example, when I first started my first lab job, probably the first week was watching people in the lab, watching videos, getting training for my lab that I was doing. And then to be compliant, each lab usually needs to do training every 6 months. So when you train, you need to train every 6 months. And usually that's done within a couple of hours. Okay, so when we use personal protective equipment, that is part of our lab safety. And you guys have all been through the COVID era, and you have probably heard way more about personal protective equipment than I ever did when I was at your age. But these are the type of personal protective equipments that we use. So we will use goggles. And we have all used goggles in the chemistry labs. Sometimes we will use what is called splash protection. And sometimes that splash protection will be a full face covering because, especially if we're dealing with bloodborne pathogens or different things, we don't want that splashing on any part of our face. So we will use a whole face shield. Sometimes we will use masks, and sometimes we will use UV light that is used to sanitize each of these things in between uses. A lot of times we have to be very particular about what type of eye protection we use. For example, if I was using a really strong acid, I would want probably a splash shield and goggles. Or if I was using something that was biohazard, I would probably just want a splash shield. I wouldn't necessarily need goggles as well. Okay, for hands, we use gloves. And there are people that are allergic to latex, so a lot of times we have to take into account people who are allergic to latex who can't use them. So a lot of times we will use vinyl gloves instead. Sometimes we will use what's called nitrile gloves, depending on the use. Most clinicians and most labs use vinyl or nitrile because they just don't want to deal with people and their latex allergies at all. Sometimes our hands, it's not just protecting our hands from chemicals or splashes, or sometimes it's as simple as using a hot pad or gloves that will protect our hands against cold. So sometimes the danger is not chemical, but it's a temperature extreme, either hot or cold. So we will use gloves that are thick and insulated for those. A lot of times in the lab we will use special clothes to protect ourselves. The standard for a normal lab is we want long pants that aren't tight to the skin but not so baggy that they get in the way. We want long sleeves. So that's why a lot of people have a lab coat. Sometimes we will have aprons as well, especially if we're dealing with biohazard material or acids or bases. We have lab coats as well, and there are other safety equipment. Some labs are even very specific about shoes that they need to have. So sometimes, actually all the time, in most labs, you want closed-toed shoes. So nothing can spill directly on your bare feet or your toes, okay? If you're dealing with a heavy-duty industrial lab, sometimes you will need steel-toed shoes. Or work boots. Okay, so it really depends on what kind of lab you are working in. All right, now let's get to the chemical safety. So in chemical safety, we use what is called SDS. These are safety data sheets. Way back in the day, they used to be called MSDSs. So those are material safety data sheets. Those haven't been called MSDSs for about the last 20 years or so. So SDS, or safety data sheet, is how they are called now. The information that are included on safety data sheets, we will find storage, how we store the chemical, what is hazardous about the chemical, the first aid that needs to be rendered. Usually the first aid section on most SDSs is pretty weak. It's basically call poison control, call the ambulance and paramedics and a physician. We will get reactivity information about what those chemicals react with, the physical properties, and how to dispose of those chemicals. Now, back in the day, we used to actually have file cabinets full of SDS sheets. Now, we don't really do that anymore. So usually, we just store these online. So a lot of people will, for their company, they will have an online database and they just store it in the cloud. Most people just Google an MSDS. So they will Google the site of the chemical manufacturer and then download the PDFs, or just Google the PDFs of those SDSs. And you will be doing that later today and looking at an SDS and telling me about the chemical that you are looking at. Okay? Biological safety. We will follow OSHA rules, NIH rules, and CDC rules. So OSHA is the Occupational Safety and Health Administration. NIH is the National Institutes of Health, and the CDC is the Centers for Disease Control and Prevention. They all have different regulations talking about safety, worker safety, health, and how we do things in the lab. So there are several lab classifications, and I've already talked about that a little bit in classes. There are lab classifications level 1 through 4. The lab classification that we are dealing with in our classroom is a level 1 and a level 2. So the regulations for level 1 they're pretty simple. We have to have PPE, so we have to have personal protection equipment. There's no eating or drinking in the lab area. Okay? Makeup, cosmetics, etc., need to be, they can't be applied in the lab. So nothing like makeup or contacts, if you are wearing contacts, they have to be done out of the lab. You can't be handling those inside the lab. Of course, you need to wash your hands as you enter and as you exit the lab. So anytime you start something in the lab, you need to wash your hands, put gloves on, and then anytime you exit the labs, you take your gloves off and you wash your hands again. You need to know what waste products you have and how to separate them. and dispose of those waste products. And I will be handling most of those. I will teach you some of it. Okay, so that's pretty much what we do even in the chemistry lab. That is a normal regulation level 1. Regulation for level 2 is all of the above from level 1, plus we add on a couple things. We have some restricted and labeled things that we need to do. So a lot of things will have these labels on it that you see below on the page. And we also need to have a biosafety cabinet. And we have a couple of those in our room. And we have to have specialized splash things. So we have to have splash shields for aerosols and foams that may be created in the lab. Okay, we need to disinfect chemical surfaces. So we need to be disinfecting the surfaces anytime we use a biological or a chemical on there. We also need to autoclave any biological agent in there, and we do have an autoclave in the room, and we will be using that as well. Okay, so a lot of these icons below, these general safety laboratory hazards, I feel like these icons are pretty self-explanatory, but I think I should go through some of them. Hopefully I can write small enough that we can, let's get this down even smaller so that I use even less room. So the skull and crossbones is for toxic material. This lightning bolt is for electrical hazard. This flame is for, of course, flammability hazard. Hopefully you can read this. This snowflake, or this is for something that is really cold. Okay. This one is for people that have pacemakers. There are some machines that people who have pacemakers cannot be around. This one, you will learn well, this is a biohazard symbol. Okay. This one is a health hazard. This is corrosive. This one is non-flammable. This one is laser. This is your eye wash station, so that you know where to find that. This is where you will find gloves. Okay. This symbol here is radiation, a radiation hazard. This symbol is an oxidizer. Okay. Both of these are oxidizer symbols. This is a UV symbol, so that has a UV radiation. This, of course, is a first aid. And this is sound. So if sound is too loud or dangerous. Okay? So you will see these symbols on a lot of our things. Now, we have hazardous classifications of materials that has been decided on by OSHA. This is the warning label that OSHA and almost everywhere in the United States and Canada and even Mexico use. So we have a 4 square that has 4 different areas. So this blue area is for our health hazards, and it goes on a scale from 0 to 4. So 0 is a normal material, 1 is slightly hazardous, 2 is hazardous, 3 is extreme danger, and 4 is deadly. And then the top square is always red. That indicates our fire hazard. And once again, scale from 0 to 4, will not burn. And this is the flash point of when things will actually catch on fire. So above 200, below 200, above 100, or below 100, below 73 degrees Fahrenheit. This is odd that it's in Fahrenheit instead of Celsius, but I guess for us Americans. And then down here, we have our instability warning in the yellow quadrant, and it says how stable that material is, whether it's stable, unstable. If heated, violent chemical change, shock, heat may detonate, and then 4 will detonate and or explode. And then we have the specific hazard in the white section, where we see all of the graphics that we just went over on the previous page. So that's where you will see those types of graphics down in the lower white quadrant. Okay, so all materials have to have this square on them with these markings. Okay, so we also in the lab, we labeled our materials, especially materials that we have made. All materials in the lab have to have a label. Okay, all labels have to tell us what the chemical is, what the concentration of that chemical is, the date that we either opened that bottle or when that material was made, and the name of the person who made it. So you need to put your initials and date on it every single time. We will practice doing that all the time. This is a way that we keep track of who made what concentration it was, and when it was made, so we know when things are past their date and have to be thrown out. Okay, waste disposal. We do a lot of waste disposal, and so here are some ways that we do that. So we clean and disinfect. So with glassware, I do have a dishwasher in the back. We will wash and rinse everything in the sink usually, and then we will wash with Alkanox and we will scrub it. Alkanox is a very special soap or detergent that we use in the lab. It's pretty mild and it doesn't leave a lot of residue. Sometimes we will just wash and rinse with tap water, and then so once we wash and rinse with the Alkanox, we wash and rinse with tap water, and then we do another wash and rinse with distilled water. That way we make sure that we have gotten all the residue off, and then after we're done with that then we air dry it in a drying rack. Okay? If we need to disinfect and sterilize something, we will remove most of the organisms. So we will remove the organisms, if I can spell. We can remove the organisms mostly. We will sterilize by means of using bleach or ethyl alcohol. Sometimes we will sterilize by using the autoclave. Sometimes we will sterilize by fire as well. Okay? So when we are sterilizing, the autoclave is basically a really fancy pressure cooker. That is how the autoclave works. So when we use the autoclave, we sterilize with heat, steam, and pressure. And we use that pressure gradient to get a superheated steam. So we usually get up to about 121 degrees Celsius using that pressure, and we use that steam to penetrate. And we usually go to about 15 to 20 psi, pounds per square inch, to try and get that pressure. So that will give us we usually use a cycle time of 10 to 15 minutes to make sure that we have killed all the bugs and all the organisms there. Okay? Bleach, the way that bleach destroys things is it destroys DNA. It denatures that DNA. So a lot of times we will use a 10% bleach solution, and that will kill most of the bugs that most of the bacteria or most of the bugs that we are going to be working with this year in the lab. Sometimes we will use alcohol for the surfaces to clean that out. We use about 70% isopropyl, or we will use 70% or above ethanol. Both of those are fairly good at killing bacteria and other organisms as viruses and things like that, so we will use alcohol for sterilizing surfaces. It does not destroy DNA, but it will destroy most bacteria and it will destroy most bacterial spores. So we will use ethanol. Sometimes we will use the heat of a microwave to destroy things. So the thing we use the microwave for is we get something wet. So if we can get something wet and we can heat it up, we will use time and heat to destroy what is going on in that. So usually we need things to go for about 5 minutes on high before we know that things are really boiled enough to be destroyed. That's usually what we use. We always, of course, need to do things in a microwave safe glass dish or something like that to get that kind of a heat tolerance going. A lot of times also we will use UV light. You've seen me use it with our goggle case before. Now you have your own goggles and you won't be using the goggles out of that case. But we use UV light because UV destroys DNA. It creates mutations. It's very, very bad for DNA. So we will use, once again, time under that DNA light to destroy that DNA to make sure that things are killed. Sterilizing solutions, we usually filter with a 22.22 micrometer filter, and then we autoclave to make sure that those solutions are sterile. Okay, so that is how we sterilize solutions and do things to keep things safe in the lab. We will talk about lab safety next time. So we will talk about how we deal with sharps, lab spills, glassware breakage, and administer first aid next time. And we will go through some scenarios next time to understand the best way to handle our lab safety. We'll see you later. Bye.